and perhaps there was life. Prepare yourself for a flight around the planet Mars with a virtual reality spin down the Mariner Valley. All in Encyclopedia Galactica. These are the first pictures of the Moon and Earth moving together in space. They came from Galileo in December 1992. Slingshotting towards Jupiter, the probe had captured a new perspective, Earth with its only natural satellite, the Moon. These close-ups showed the lava fields of the Moon, differentiated in false color. They were a chance to test Galileo's equipment, for in 1995 the craft will be imaging the moons of Jupiter. Meanwhile, Galileo was over the lunar North Pole, a region difficult to see from Earth. Like much of the surface, it's pocked with craters, the impacts of meteorites during 4.5 billion years. An ancient, barren terrain untouched by wind or weather. Although there's no air to breathe, the Moon is ripe for colonization. Next century, there's every possibility that permanent lunar bases will be under construction. They'll be like Antarctic research stations, but more self-sufficient. A network of pressurized modules to sustain human life. Oxygen may be produced from lunar rock, and water by chemically combining oxygen and hydrogen. Biospheric tanks will be the farms of the Moon. Augmented with organic fertilizer, food crops will grow in lunar soil, in lunar greenhouses. From these bases, pioneers will explore the Moon. They'll travel much further than their 20th century predecessors. The search will be on for industrial opportunities, like mining raw materials. And there'll be science, radio astronomy, free from the noise suffered by receivers on Earth, and photography, cosmic pictures without atmospheric distortion. This is the Moon from Earth. And these are scans through a telescope, like the view from an orbiting satellite. A huge crater, and mountain ranges reminiscent of the planet Mercury. The bright highlands, peppered with craters. The dark seas that cover 15% of the surface. In fact, they're impact basins filled with ancient lava. Flat expanses contrasting with the rugged uplands. And again, from over 400,000 kilometers away on Earth, the crater Copernicus. Our view of the Moon is constantly changing. If observed at the same time every night, the Moon shifts to the east, and its phases change from a crescent to a full moon and back again. One thing is constant. The Moon always presents the same face to Earth. That's because the Moon turns once on its axis in exactly the time it orbits once around Earth. So, whatever the phase, it's the same old face. How much of the face is in light depends on its angle to the sun. At new moon, we see nothing at all. The shadow is total. It's not Earth casting the shadow, but the moon itself in relation to the sun, a continuous monthly cycle. A view from over the poles has the moon and Earth catching sunlight from the right of the picture. As the moon orbits Earth, so it waxes and wanes to an observer on Earth. The cycle takes around 28 days. Here it is again, with the central frame showing the moon phase we see on Earth. Like the moon, many planetary satellites are trapped into showing the same face. Only if the moon's orbit stopped would its rotation be apparent on Earth. Compared to Earth, the moon is tiny. It would fit across North America. Earth's diameter is 4 times the moon's. Earth is some 12,700 kilometers wide. 30 Earths would reach the moon. Such proximity means the moon exerts a strong gravitational pull. Witness our ocean tides. The moon tugs on the oceans. A combination of its orbital movement and the rotation of Earth causes an ebb and flow that can make an island out of a promontory. This is an eclipse of the moon, caused as it passes through the shadow of Earth. On average, there's a moon eclipse once a year. With Earth starting to blot out light from the sun, the shadow on the moon appears red. The shadow is much bigger than the moon. Our dusty atmosphere bends the light of the sun to produce the red glow. While a total solar eclipse lasts minutes, a lunar eclipse can be hours. This one, in 1992, had a black shadow, clearly showing the curvature of our planet. The moon is 400 times nearer to Earth than the sun, an amazing coincidence, especially at a solar eclipse, when the moon's shadow scoots across Earth. Now, because the sun is 400 times the diameter, the moon can fit exactly over the disk of the sun, a total solar eclipse. Sometimes the moon isn't quite big enough. This is an annular eclipse. The reason is the moon's elliptical orbit, which periodically takes it slightly further from Earth. The moon is our nearest neighbor, the second brightest object in the sky. We know that moonshine is reflected sunshine and that men have walked on the moon. But what's its origin? Is it the child of Mother Earth? Very possibly. For shortly after Earth had formed, it's believed to have been struck by another protoplanet. As it reformed, lighter material was blasted into orbit to become the moon. Gradually, it cooled. A lunar crust solidified. But over eons, the moon was bombarded by cosmic debris. Great basins were left. They filled with molten rock flowing from the interior. These hardened to shape the moonscape we know today. Stay with us after the break when we take you to the red planet, Mars. The pictures from the Viking explorers and the very latest in virtual reality spaceflight. September 1992, an American spacecraft heads for Mars, a quest to the red planet. Less than a year later, as it tightens into Martian orbit, a mapping mission is underway. Familiar terrain for Mars has been much studied as man's next stepping stone in space. This is Mars in a small telescope, the image shimmering through Earth's atmosphere. And this is Mars from the early 20th century, drawings by astronomers who believed they were observing canals. And here's Mars from Earth orbit, through the clearer, steadier eye of the Hubble Space Telescope. But no canals. Mars, bottom center, is the fourth planet from the Sun. Its solar orbit almost 2 Earth years. They've much in common, but Mars is only half the size of Earth. It's also less dense, has weaker gravity and a thinner atmosphere. But it does have polar caps, seasons and a tilted axis. Without the cloud and atmospheric problems of the Venus probes, Martian explorers have delivered pristine data. They've photographed valleys and channels, morning frost and fog, great canyons, even a landslip. Here again, closer to. The atmosphere in profile, and ice. A flyover reveals a thick polar cap. From Earth, the northern cap can be seen by telescope. In summer, the cap recedes as winter grips the southern pole. This southern cap is largely frozen carbon dioxide, the northern water ice. The caps are riven by great terraced crevasses. They've been formed, it's thought, as the climate has repeatedly cooled and heated, erosion caused by melting ice. From the poles outwards, the Martian surface has been shaped by wind and weather. And by impact crater, Mars is peppered with them. Volcanism has been important too. This is Olympus Mons, the biggest volcano in the solar system, an appropriate springboard from which to fly this dusty, arid world. Hoving into view, the 3 volcanoes of the Tharsis Ridge. To their west, Olympus Mons. Little wonder astronomers mistook the surface shadings for canals or continents, even vegetation. In fact, they're differing geological textures. Now, with data compiled from the American Viking probes of the 70s, we swoop on this desert landscape. First, a glide over Mariner Valley, the planet's most extraordinary feature, a rift that could stretch from coast to coast of North America. There's cloud below as we position for a swing over the Tharsis volcanoes. Martian cloud, like Earth's, is water vapor, but there's less of it. Overnight frost, burnt off by sunshine, forms mist in the canyons. Mars is chilly, but near the equator at midsummer, the temperature could reach 25 Celsius. A low-level turn for a buzz down Mariner Valley. And there's Arcia, the southern triplet of Tharsis. Pavonis and Escreas. Three gigantic shield volcanoes, like those that sprang from the Pacific to form the Hawaiian Islands. Mars has two little moons, Phobos and Deimos, probably captured asteroids. Pictured by Viking, they are lumpy rocks measuring just a few kilometers. Phobos is heavily cratered. Deimos is smoother and smaller. Both have dusty surfaces. The Soviets had an ambitious plan to explore Phobos, a craft to drop probes on the surface. Sadly, just as their work was to start, contact was lost. This was the best image received on Earth. A Martian dawn in 1976. Within weeks of each other, the Americans had soft-landed Viking 1 and Viking 2. This is what they found. A lifeless desert, rusted red by iron oxide, midday temperature -30 Celsius, atmosphere carbon dioxide, 150 times thinner than Earth's. What they didn't see were the great dust storms that blow up on Mars. So big, they can be filmed from Earth as the whole globe is enveloped. But the Martian climate hasn't always been so bleak. Witness these river-like channels. And this teardrop, molded surely by flowing water. It's believed Mars once had an atmosphere as dense as Earth's, and water galore. So why did the rain stop? One theory is weak Martian gravity, leaking atmosphere into space. No problem while volcanic gases replaced lost air. But when eruptions ceased, Mars was in trouble. The protective blanket of water vapor and carbon dioxide, which had trapped the sun's heat, disappeared. Mars became a desert, devoid of warmth and water. Future missions may yet detect water frozen beneath the surface. And mobile robots will search for life. It's a slim chance, but some biologists believe single-cell organisms could lie dormant in the Martian soil. Samples will be collected for dispatch to Earth. But who knows when man will land? Mars, of all the planets, is the closest thing to home. There are even 24 hours in a day. Next time in Encyclopedia Galactica, we go further out into space and visit the gas giants. Jupiter, the colossus of the solar system. Pictures from the Voyager spacecraft of the biggest planet and its many moons. And then Saturn, the celestial classic, with images of her rings, moons, and awesome weather systems.